Okay, welcome to day 10 of Advent of Code. Um, I am using completely different software setup this time. I believe I am live streaming, although I'm not 100% sure about that. Oh, if we weren't streaming before, then I think we're streaming now. Um, as usual, I guess we should start by reflecting on what we learned from the previous day, right? So, what did, what did we learn from day 9? Um, well, I mean, this is something that should be evident if you've watched many of these. The easier and more trivial the code, the more flustered I seem to get writing it. Um, and that's just a property of partly having eyes on you, but also easier code doesn't engage your brain as much, so you're likely to kind of overthink it. Um, and also, like, I mean, the routine that I wrote to come up with the four neighbors, four at most, and I wrote what 15 lines of code to come up with four neighbors. I mean, that's screwy. Obviously, we could write it a little more cleanly, but kind of one of the reasons that this kind of code just makes me seize up is I kind of don't know an elegant solution to this because it's all special cases. I mean, I suppose I could create an array of all the possible ones and then pass it through a series of filters, and I guess that's sort of elegant. I don't, but not really. So I don't. If someone has a truly beautiful code structure for doing something so kind of inherently blah, I'm all ears, right? Um, we we the royal we. I didn't realize that actually when I was doing the comparisons, ba ba da ba da. I guess in the first part, lows. Um, I changed this just for the second part, right? Because I believe in the first part I was just comparing the characters directly. And I guess that means I didn't need to change this. Maybe I'm not even keeping track of what I actually did in real time. But it's possible that we did the first part just doing character comparisons, which is a weird thing to do, but it happens to work for single digits, because the characters compare that way, I believe. So that's worth keeping in mind that we might have gotten away with doing something a little sketchy. And I mean, it's this thing I've mentioned in several reflections earlier that marshaling your input as soon as you actually read it in is probably the right thing to do. And kind of every time I don't marshal and end up marshaling after the fact, it ends up just looking a lot kind of uglier, right? So, yeah, it is what it is. It would have been nicer if we worked with ints the whole time instead of characters. Also, I mean, it doesn't matter for a programming contest, but it's more general, like just 9 digits. I don't think that's the way real submarines do depth mapping. Just a theory. Okay, and let's also look. So I wrote this little Q class, which actually we can look at the Q class because we have a little time. Let's make it bigger so other people can see. I wrote this completely trivial Q class, right? And all it really has in it is a push and a pop, and the pop returns an optional, right? And that means that the way you get things out of your queue is with a loop that looks like this. And it's my opinion that that's a beautiful code structure. I mean, particularly the fact that you can put let statements inside loop conditions and everything. I really think that's a beautiful kind of a loop. And I've seen people write containers like queues and then build iterators so that they can write for loops across them that repeatedly pop. Um, and I I don't know. I find that just really awkward because of course a queue is defined by the limitations. It's not a linked list, even though we happen to use a linked list for this particular implementation. It's a queue, and all it has is a head that you can get at. Everything else is beyond your reach, and that's why a heap is a priority. It's just a different kind of queue that internally orders its things all differently. And a regular queue is just first in, first out. But anyway, I like that code structure, and I think it is underrated in programming. I also noted that on the first pass, because I did a breadth first search here, right? And I pushed my low point into the queue, and I set up my basin, and then every time I visited something new, I pushed it into the queue and I inserted it into the basin. Of course, we should have really put the low point into the basin as well, because now we're actually going to visit that low point twice, which isn't really a thing in terms of performance. It doesn't matter, but anyone looking at this code would make the assumption that all the nodes are visited only once, and that's not the case. So it's kind of a latent bug. If anyone took this code and extended it, making use of that assumption, it could introduce a bug. So, and on several of these puzzles, I have done something like this: checked whether something contained something, and if it didn't, inserted it. There is an idiom, and in Swift, I think we said maybe last time, that insert returns a tuple with named fields. So if you just do insert.inserted, then you can try inserting something, and if it goes in there, do something, or if it didn't go in there, do something, right? So that would be the more compact way to do this. It would save us a line of code. But the thing is, as soon as I write this if, insert a thing inserted, a whole bunch of alarms go off in my head, because anytime you have a mutating function inside an if condition, it's very easy to forget to add additional constraints to that condition and forget about short circuit evaluation, and end up sometimes the side effect that you want to happen all the time only happens depending on other conditions, and that's quite confusing. I have certainly... Oh, sorry, I should enter a focus mode here. Focus. Don't disturb me. Okay. And I have certainly... I can't recall doing it in my own code, but I have certainly come across that bug in other people's code multiple times. So every time I see kind of a mutating thing in a condition, I get a little on edge. And anyone who is watching this and then looking 2 lines above in my reflections and saying that I think this is a beautiful thing, it has a mutating function in there, well, you just don't get it, man. And it is beautiful, and I don't need to be perfectly consistent about this stuff. So, anyway, it looks like we are already coming up on time for day 10. So, let's see what day 10 has in store for us. Oh my. Let's look at what this input before we even read anymore. Oh, it is ugly, isn't it? Oof. So. Okay. So, what does all that mean? So this looks like a pretty straightforward parsing problem, I think. So we want to get rid of the corrupted lines. Okay. First, okay, fair enough. So, um, uh, parse trunk. I don't think this even needs to return anything. So, we say, string, this is easier than dealing with the true iterator types in Swift, and I have extended the string class so that you can index by integer because I'm cheating really. So what do we want to do? Wait, so what is a chunk? I've actually forgotten how to parse anything. I don't think I've parsed anything since last year. Chunk was close. So a chunk contains 0 or more other chunks. So, no. Okay. Um. Uh. If. Um. If. Oh no. Um. God, what is the syntax for this? Ba 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 ba. Um, no. I don't think that's the syntax, but we'll wait for our error and then. Wow, it really doesn't think it's the syntax, does it? Not even close. What does it think is wrong everywhere? Where's the in out? I always forget in Swift where the in out goes. So I think all our Swift syntax is wrong. Let's get our syntax errors and repair them, because this is ridiculous coding all this stuff that isn't even going to compile. Where do we even start? Expected colon. Is it in out int because it's part of the type? Is that how it works? So we can find our first error. Okay, expected colon after if. And s pause was contains? Is that a thing? I don't know if that's a string routine. Character and string. Yeah, okay. Let's see if we can just force this to be a thing. Oh, look at that. Okay, so so what happens? It returns, let's say, yeah, we're gonna use sentinels, even though sentinels are an ugly way to do things. Okay. If it closes with the wrong. Okay, so if it's one of those things. No, that's fine. Hold on. So if we've hit the end of the line, then I think we can claim success. And let's say nil is success, which is also a super weird convention. And then pause. Okay, and otherwise, it's I should have thought through my strategy before writing any code. Okay, so we're going to look for, when you parse a chunk, if you either start with a delimiter, right? That's what starts a chunk, is seeing a delimiter. So if you don't see a delimiter, then that was a 0 length chunk, right? And that means you should quit parsing. So this is actually parse chunks, right? It's not a hard puzzle tonight, but I seem to be off. So what is the logic? You look for opening delimiters. You need to find an opening delimiter. And then you parse chunks until all the chunks are parsed. So you repeatedly parse chunks until parsing chunks fails cleanly, returns cleanly, and then the next character needs to be a closing, needs to be your matching closing delimiter. Okay, and if you're at the end of the whole thing, then it's incomplete. And if it's not your closing delimiter, then it's corrupt. So what is this middle? You parse chunks until you exit cleanly. So, what can we return? So, delimiter is that. Where's that? Parse chunks s. Move the thing along. So now it's done and there are no more chunks open. So if pause let's say equals this is what I was meaning about passing a sentinel. It's an ugly way to convey things. We should make an enumeration or something like that, but whatever. Else if oh no, that's not right. Is not equal to closes of my delimiter, then that's our syntax error. You know what? I am actually going to open these things up because it's ugly, and I am all about being beautiful. Despite the fact that we have some semi-syntactic nonsense right now. Okay, otherwise, keep going, right? Okay, so that's the heart of it, but what we're doing outside, because we're doing a loop. So, what are we doing? And they're both those things. So while, and I mean, it's super weird to be checking this twice, though, because we're doing this inside the loop as well. But this is us trying to start a new one. And so this is actually success. So that's fine. So if we exit, okay, that makes some sense. So if we exit this loop, we can just return nil, which means we parsed our chunks and now there's something that's not a chunk anymore. So, if let and is this an else? I mean, these are all returning, so it's not like it matters, but I don't know if we got that right. Let's in data Do do do. C is come on, Rob. 0. Are we incrementing pause correctly? Let's pause. Here we go. Pause plus equals 1. That's better. And we are passing it. Parse chunks. Yeah. Okay. We'll do the scoring in a moment. Okay, let's see if this even compiles. No. Substrings are so annoying. I guess really we should have taken a string protocol as a parameter. Cannot pass immutable. Oh, yeah, it doesn't look crazy. Okay, so what's the scoring on this? We've been very slow, but fine. Is there a what's the pass statement? It's break, isn't it? Yeah, okay. Switch. First, illegal character? What were our illegal characters? Oh, they are always the wrong closing delimiters, aren't they? Oh, interesting. It didn't need to be that way, though, right? Most syntax errors are not so well behaved. What is the relationship between these numbers? They look familiar to me, but not familiar enough for me to place them. 2, 5, 1, 3, 7. And we need a default, don't we? Because this would come up in real data. You'd hit the default, but so. And, I assume those are all unnecessary. Okay. I wonder if that's the right answer. Total error score. Yeah, okay, fair enough. Let's move on to part 2 and copy this. Okay, discard. Incomplete. Sequence of closing characters that complete all open chunks. Yeah. This is not hard to do with our current thing. Completion string. So, what we now want to return is a completion string, right? What are we doing? Well, actually, hold on. Let's read the whole thing. So, multiply. Wait, start with the multiply score by 5 and then increase by the value. Okay, yeah. So it's kind of a base 5e thing. So how are we passing this out of this? We only have to return one thing per level of recursion, right? But so let's, I mean, this is pretty lazy. But completion out string. So, okay. If equals parse chunks. If because that, and then the next level above puts it after. That seems right. So if a level below said that it was incomplete, then we will add our thing and then return. And are we double doing this? Because this is the first time we encounter it, so we just do the same damn thing. It's not a pretty code structure that we're duplicating, but okay, so if let's equals parse chunks and C space. So var. Ooh, and we have to remember to pass S in our recursive call, don't we? Which we didn't do. Parse chunks. Oh, are we reusing S? It's L there. Okay, all a bit ugly. Space. I'm a very slow programmer. Okay, and then for C in S. Output 1, 2, 3 for curly, 4. I don't know if I got it, but let's try it and see our errors. Yeah, okay. Space. Didn't I declare space? What? 34. If let space what? Let why did this work when it was C? What have I done? Why did that work when it was C? Oh, can you not use the... Hmm. Um, oh, well, let's change it back to space. Uh, if... Come on. Space... I should figure out why that didn't work. We have plenty of other stuff to do, though. Oh, come on. What's the error? Leave option. 13. If of course. Let's see. That's in 17. If... Oh, what am I doing? That's stupid. We just need... come on. Oh, well, that's more interesting, isn't it? What happened? Well, let's... Does that get us anything smarter? I really don't want to have to actually drop into a real debugger because that always takes a while, and you know, we're on the clock here. So but I really don't know where this is going all wrong. So, my. Well, oh, but then we need to set up the AOC lib library path. Is it the... equals... okay. Let's see what happens. Wait, what? What? Oh, it... Sorry, this was just loading libraries. Libraries not loaded. How do we... oh my god. You know what? I really don't have the patience to do that right now. Let's try parse chunks. Let's see how far we get. And then did we parse, and so we did get through a couple, and then we crashed. Can't believe we are not getting real signals here. This is really the problem with not running in Xcode. Space. What? Why? Yeah, this all looks good. So, it was in the middle of parsing. What's different? Oh no, parsed. It was in the parsed, okay. Parsed, and then S is all of that. Did my assertion actually trigger? What is it? Does it take another? It's gotta at least tell me something if my assertion triggers, doesn't it? It would be very stupid if this is all we got. Well, I don't even know about assertions now in this mode. What? You. Oh, no. Parsed our thing. That's my for. That's my if. That's my line. I don't really understand what's going on. Is there our scoring function is what's crashing? Is that? Do. Do. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. So it's the last character. How is that a thing? Well, I know this is incredibly boring viewing because debugging is incredibly boring viewing. And it ends, but it's that right angle bracket while it's doing character right angle bracket. Is output overflowing or something? Oh, it looks like it is overflowing. Oh, because we're doing it for every line. Okay, yes, we're overflowing output because I didn't read this correctly. The winner sorting all the scores and taking the middle score. See, there's a whole paragraph that I didn't read. Read the problem. I'm such an idiot. Okay. Zero. Just before we do that, outputs and output. Okay. Outputs count. Let's actually sort outputs. Now, I don't know if it should have a +1 or not or whatever, but let's try. And we're going to get a lot of output. Ooh. And we're going to get a lot of our debug print statements, but this should still be the last thing. So let's try it, and then we'll get a 1-minute timeout, and we'll have to think through more closely. Oh, well, okay, we got it. Ooh, but we were very slow. What is that? That was a 40-minute problem, and that was not a 40-minute problem at all. Well, okay, fair enough. But we finished it.